Hello mga ka-online! Ang topic namin ay tungkol sa spline interpolation. Spline interpolation is a form of interpolation where the interpolant is a special type of piecewise polynomial called a spline. So this is an alternative approach to apply lower-order polynomials to a subsets of data points. So ang mga connection or connecting polynomials ay tinatawag na spline functions. Makikita natin sa figure na ito kung saan nagmula ang konsepto ng spline interpolation. So this is originated from the drafting technique of using a thin, flexible strip, yun nga, yung tinatawag na spline, to draw smooth curves through a set of points. So, base sa virtual representation nito, meron itong mga pins na nag-i-illustrate ng data points at yung flexible strip which is yung spline. So, kung mapapansin nyo sa bawat endpoints, may straight na spline o tinatawag na natural spline. Dito naman sa representation na ito, sa figure na ito, mapapansin natin na ang spline ay mas maayos mag-perform kesa sa higher order polynomial. This is the case where a function is generally smooth but undergoes an abrupt change somewhere along the region of interest. Ginagamit ang spline para makabuo or makagawa ng smooth curve. So kung mapapansin natin sa A through C, A, B, C, it illustrates how higher-order polynomials tend to swing through wild oscillations in the vicinity of an abrupt change. May tatlong uri ang spline interpolation. Una, linear. Pangalawa, quadratic. And then a cubic spline interpolation. So, unahin natin ang linear. Ang theory ng linear spline interpolation is kapag binigyan tayo ng n+1 data points from x0, y0, all the way to xn, yn, at i-interpolate natin yung data na yun using linear spline. So, kailangan nating maintindihan na sa bawat values ng x0, x1, and so on and so forth, kailangan natin silang ma-rearrange from ascending order o sa pagkakasunod-sunod para hindi tayo mahirapang makita kung saan naglalay yung given point, given data point. Kapag hindi naman binigay na naka-descending, ascending order yung example, yung given data, i-change natin. Change it accordingly. Babaguhin natin yun. Makikita natin yun sa example. So, linear spline is the connection from one point to another using a straight line between consecutive data points. So, ang main formula niyan is mi is equal to fxi plus 1 minus fxi over xi plus 1 minus xi. Sa linear spline, point-to-point basis lang din to. Kung halimbawa may hahanapin tayong value from one point to another, walang consideration yung other data points doon. Doon lang tayo magfo-focus sa gusto nating kuhanin na data. Ang pinagdudugtungan ng dalawang line, dalawang subset of points, ay tinatawag na interior knot because it's shared by two lines. May limitasyon ang linear spline. Una, it's not able to use the information from the other data point. At pangalawa, the derivatives are not continuous. Pupunta tayo sa example para mas maintindihan. So, example. Fit the data in table with first-order splines. Evaluate the function at x equal to 5. So, yun nga, yung sa nabanggit ko kanina sa linear interpolation, dapat kailangan muna nating i-rearrange yung given data, given value sa descending or ascending para hindi tayo malilito. Pero dito sa binigay niya example, naka-arrange naman siya from lowest to highest. So, ang x equal to 5, ang 5 ay naglalay between 4.5 to 7. So, solution, this data can be used to determine the slopes between points. For example, yun nga, interval siya ng x equal to 4.5 to x equal to 7. The slope can be computed using yung formula kanina. M sub I is equal to f of x sub I plus 1 minus f of x sub I over x sub I plus 1 minus x sub I. So, direct substitution lang din yan. So, m is equal to 2.5 minus 7 over 7 minus 4.5 is equal to 0.6. So, mayayari niyan, 4.5 plus 7 minus 4.5 over 7 minus 4.5 times x minus 5 equal to 1 plus etong buong slope m, which is 0.6 times the x minus 5. So, 1 plus 0.6 times 5 minus 4.5 is equal to 1.3. The slopes for the other intervals can be computed, and the resulting first order splines, the value of x equal to 5 is 1.3. Ang pinagkaiba ng linear sa quadratic spline, yung linear, it has two consecutive data points only and discontinuous interior knot. Pero ang quadratic, we just simply draw a binomial going to data points at may equation siya in between two data points. At meron din itong 3 unknowns, 3 equations. So, each spline goes through 2 consecutive data points. Also, each spline has a same slope at the interior data point. So, the polynomial for each interval can be represented generally as f of x sub I is equal to a sub I x squared plus b sub I x plus c sub I. So, the function values of adjacent polynomials must be equal to the interior knots. This condition can be represented as follows. So, yung pangalawa, the first and last function must pass through the endpoints. May additional equation yan. 2n conditions. Third, the first derivatives at the interior knots must be equal. Therefore, the condition can be represented as follows. And last, assume that the second derivative is 0 at the first point. Example, fit quadratic splines to the same data used in linear example table. Use the result to estimate the value at x equal to 5. So, ginamit lang din dito yung example dun sa linear spline ng table, given dun sa table. Dito meron tayong 4 data points, 3 intervals, 9 unknowns, and 4 conditions. So, passing sa first and last function ng final and initial values, magdadagdag tayo ng dalawa. Ito na yun, 9a sub 1 plus 3b sub 1 plus c sub 1, so on and so forth. Continuity of derivatives creates an additional 3 minus 1 is equal to 2. So, ayan na yun. At itong condition na to, pwede tayong gumamit dito ng matrix form. As, ayan, given, as shown. So, these equations can be solved using techniques from matrix form and can be substituted into the original quadratic equation. So, pag nakuha na natin yung values, i-substitute lang natin yan sa original quadratic equation. When we use F2, the prediction for x equal to 5 is therefore equal to 0.64 times 5 squared minus 6.76 times 5 plus 18.46. This will be equal to 0.66. Thank you.